And we should be live. Hello, hello, hello. Welcome all to the BPS 1 year delayed Patreon live stream extravaganza to the stars. Welcome back, everybody. You already know what it is. It's your boy, Joseph Bislington, on Wednesday, February 21st of 2024. Our plan today is the same as always. We are going to be looking at a Patreon weekly or bi-weekly update video that was published roughly 1 year ago. So the video we're going to be looking at was published on February 17th of 2023, and we're just going to see what I was doing a year ago. And of course, the reason that we do these, I have to plug it, but the reason we do these is that I make these videos on Patreon once every 2 weeks. It's been an awesome exercise in just like posting and staying on track with deadlines and things like that. And if you want the live updates about what's going on right now before it comes out on the main channel, that's the best way to do it and to support the project. So I just published one last night where I was super excited because I have a bunch of CFD results that just got validated with a bunch of cool flight data. And if you're interested in that, you know where to find it. With all that said, let's just jump into it here. I'm feeling awfully sporty and goofy today. So, yeah, that's all I got. And, you know, as always, we've got the Dr. P with us, Dr. Pepper. Give it a nice little ASMR. Beautiful. Okay, let's just jump into it. So once again, we are looking at a video that was published 1 year ago today. It was on February 17th, and we are going to scroll back to the beginning and watch it. So I haven't watched this before since basically a year ago. One thing to note about this one, I actually did push this one a little bit public. So if I scroll down, you can see it says 947 views. That's not all patrons. That's because I posted it on Twitter and I was trying to get people to sign up. It's like a little advertisement, like a little cheeky, hey, you should sign up for this. But anyway, let's get started. Hey patrons, welcome back to another 2-week update. It is February 17th of 2023 today, and we're just going to jump right into it. I am doing a voiceover because there is so much footage and so much to cover, so let's do it right now.
Love voiceover.
Last week we talked about the CAD of the rocket motor, and this week I started building. Namely, I started building the nozzle section and the forward closure. So the first part of the nozzle section that I built is out of these 3 blocks of phenolic. Basically, we want to turn these phenolic blocks into round pieces. Now, you can buy phenolic rounds, but they're a lot more expensive and they're hard to come by. And so in the name of keeping costs down, motor per motor, it's easier to, I think, build this and spend a little bit longer to cut these things out with a hole saw. Then I glue them together. I use rock epoxy to glue them together. This is not a guarantee that this approach is going to work, but the part is like largely in compression, so it should be pretty safe to use. Just pausing here for a second. I said that I was going to be doing this for all future motors because it's a lower cost. I ditched that idea. It comes out to about $220 per phenolic round if you order like 14 of them at once, and that's what I did. So we're not doing this approach anymore for future motors, but it does work. And as a one-off, it is cheaper. Like a regular-ish epoxy like that. And, you know, of course, if it's wrong, we'll find out. Anyway, these are in 3 pieces because they have to get cut out with this hole saw. Basically, you could buy one big, thick block and turn the whole thing down in the lathe, but you wouldn't be able to do that with a hole saw. The hole saw isn't deep enough to actually get through and turn this whole thing into a round part. So the name of the game is basically like remove all of the material that you can before you have to start removing material and turning it into chips and dust, which is what happens on the lathe. So we take the hole saw around the outside. We also take the hole saw to the inside of some of these round parts, basically just trying to get rid of that middle material that we don't need. It also makes it a little easier to start working on the lathe. And then once that was done, like I said, I glued them up with rock epoxy and I compressed the crap out of them with 4 trigger clamps and let it sit for 48 hours. I didn't heat treat it. I didn't try to heat cure it. I wanted to let it just happen naturally over time. And I think it probably doesn't make a huge difference. I've just had some problems in the past with accelerating the cure time using heat. One thing you'll notice in most of these shots is that I'm wearing a respirator, and this is probably something that doesn't need to be said, but I'll say it anyway. Safety is really important here. A lot of the materials that get in the air, even if the materials aren't like toxic themselves, they are not good for your lungs if they get in like a small enough particulate size. It's just not good to breathe anything that isn't regular old air.
Yes.
So the respirator is really good for stuff like phenolic, stuff like graphite, which we will see coming up right now. So once these parts were compressed and like the epoxy was curing, the next step for me was to turn the like graphite throat of the nozzle on the lathe. So here's the thing about graphite is that it's kind of wonderful and also terrible to work with. Graphite has incredible heat resistance. It won't melt, it won't erode away, it just sort of sits there and takes it. And this is good and also bad. It does mean that you have to insulate any material that touches the graphite because the graphite becomes, basically as hot as whatever else is touching it. And then we'll transfer that heat directly into it. So that's kind of why we need this phenolic section in between the graphite and the aluminum. But anyway, we're getting off track. Graphite is hard to work with because it's also an abrasive material. And this is a little counterintuitive because you see graphite advertised as a lubricant sometimes, as like a dry lubricant. And that has more to do with the shape of the graphite particulates, I think, as far as I can tell. Okay, pausing here really quick. I cannot tell you how many people got upset with me for claiming that graphite would abrade away the ways on a lathe. So that's so many rhymes right there. But like, I can't tell you how many people commented on the Nozzle video for Simplex saying that I was wrong and graphite is a lubricant. And I'm telling you, every single machinist I have talked to said, do not let the graphite dust get on your lathe. So like, I'm not wrong. Anyway, I feel very passionately about that. I said graphite can abrade away the ways of the lathe, and everyone believed that it was wrong. But like, no, don't let it touch your lathe. I'm not an expert, but the thing that I do know is that if you're turning or milling graphite, you have to protect both, obviously, your lungs, but you have to protect... Wait, pause. I think I just inserted an ad. Sorry, it suggested that I insert an ad, and I clicked on it because I thought I would get more details, and then I think it just did it. If you're getting an ad, let me know. Excuse me. We'll pause for a second, just in case. Whoopsie. Sorry, fellas. Sorry, folks. No ad for me. Yes. Okay, sounds like some people are getting ads. Yeah, my bad. I'm not trying to like advertise out the wazoo here, so we'll give it. Okay. No ad, only subtract. All right, cool. Well, let's continue on then. Protect your machines too, because if the graphite gets on parts that need to slide together or like slide across each other with pretty tight tolerances, so on a lathe you're thinking about the ways, you're thinking about the lead screw. On a mill you're thinking about any type of travel or like things that slide against each other. I don't know how to explain it better than that, but anyway, it's an abrasive material, and so if it like gets in there, you end up hurting the machine over time. And so all of that is to say that I turned this graphite part outside in my backyard. I took my little eBay lathe, I rolled it out back, and then I covered everything that I could in wet paper towels. I also used a shop vac with a HEPA filter on it to try and suck up as much of the dust that got like spewed into the air as I could, and that worked quite well. That was really important for reducing the amount of graphite that went other places. And then the wet paper towels just help get the graphite to stick to it. Like once the graphite falls on a wet paper towel, it's more likely to stick there than if the paper towel was dry. And it was a long process. It was a long day, but it was also kind of wonderful. Like I've never had to do machining outside, and it's kind of... it was kind of peaceful. One thing that I still agree with that. One person says, Justin here said, are you covering up your old selfie cam again, or you didn't have one on this video? There's none on this video. Woo! Here I go. There's no selfie cam on this video. It's just voiceover. I've learned so far in making this nozzle is that tapers on lathes are tricky to do right, especially if you have a cheaper lathe where you don't have a digital readout or you don't have a way to super precisely measure some of the angles or the distances that the lathe is traveling. It becomes difficult to match angles that you cut across different objects. So if you look at the way that the nozzle is constructed, there's a lot of like angled parts that have to fit together. And let's say you're off by 1 degree on one of those parts, you reduce the area of contact between those two parts quite significantly. And so that like you end up with sharp edges again, which is the thing that you're trying to avoid with these tapers. So all of that is to say that I think for the next motor that I do, not this one, but whatever I build next, I'm going to redesign the nozzle to have slightly like sharper corners.
Yeah.
Not sharp corners, but slightly sharper ones.
Still agree with that.
This was a pain to make, and it also makes it really hard to grab onto with the lathe. If everything is an angle, it's hard to do work holding. After finishing the graph, I didn't talk about that in this video, and I don't remember if I talked about it in the simplex video, but I had to think really hard about order of operations for the nozzle because, like, genuinely, there is one surface that you can grab onto that is not a taper. So I had to do all of the stuff on this side last, I believe. I had to do all the stuff on this side last because this was the only section that I had no taper on, so that was the only section that I could reliably grab onto. It was kind of weird. Fight throat, it was time to turn back to the phenolic part of the nozzle. So once the glue had dried, also, yes, Mark, a lot of the phrases are the same as the simplex nozzle videos. I mean, this stuff is like largely covering the stuff that I cover in the main videos. There's some stuff that doesn't get covered in the main videos, but you get to see like what was happening exactly 1 year ago. So the simplex stuff, I covered it in a maybe more polished way. And then some of the stuff that comes out in the Patreon videos like don't make it to the main channel. I started turning this thing down on the lathe. I started with the outside of the part and turned it to the final widest diameter, and then later we're going to cut a taper, but then I moved on to the inside of the part. I did most of this using a pretty wimpy boring bar. I just didn't have the right size boring
This is all
bar
in the main channel video
with me. And like the one that I used worked well enough for phenolic, but as soon as I got to the aluminum, it was a problem. Anyway, cutting the taper is the same story here as before. When you're working on a lathe that did not cost that much money and got shipped from eBay in a sketchy kind of way. You know, the parts aren't going to come out amazing, but it should be good enough for a first motor. I'm doing these parts back in my garage at this point. The phenolic parts and the phenolic dust isn't nearly as bad as the graphite stuff is. And I'm still trying to evacuate most of the chips and dust with the shop vac while I'm going, but the phenolic is not going to decrease the life of the machine. All of this stuff, by the way, for the future rocket motors that I build, all of this stuff is going to get done on a bigger lathe, minus the graphite probably, but like, I think the better approach is to have a bigger lathe with lots more torque and to take slow, chunky passes rather than like, you see, like all of this stuff is just dust and particulate in the air. And then that ends up settling all over around the garage. And yeah, for future stuff, you want like slower feeds and speeds so that you don't create as much dust, but you create stuff that settles more easily in the shop meaningfully. After cutting the inside, I started cutting the outside. Once again, this is like a fairly long taper, at least relatively speaking, and it makes it a little bit tricky to machine. The goal, of course, is to avoid stress concentrations by avoiding sharp angles, but it's a trade-off.
I love that shot.
It becomes a little bit harder to machine on a crappy lathe. After this, I turned the top of the phenolic part of the nozzle. This is a separate piece that helps guide the exhaust flow into the throat of the nozzle. So it's basically the top of the converging section before you hit the throat and then hit the diverging section. Okay, and then after all of these phenolic parts, we've got the top, we've got the side part, we've got the graphite throat. It's time to make the nozzle carrier. So this is the big piece of aluminum that's going to let the O-ring seal against it.
This thing was terrifying on the eBay lathe. I never want to do this ever again on an eBay lathe. This is genuinely terrifying to do because it's a big hunk of metal. Be the place that the radial bolt's attached to, and it's going to hold all of the other things. Once again, it is the same story here. We have tapers on this part that like I would love to avoid in the future if possible. Turning down this piece of aluminum was also really not great on this lathe. I know I keep mentioning it, but the quality of this machine is quite poor, and I was really hoping that I could get away with just using this specific machine for a few years, but I'm starting to think it may not work well as we scale up a little bit more. Basically, the outer diameter of this stock material is 6 inches. We need to turn it down to like 5.75 inches. But even though the lathe advertises a swing of 6 inches, like the ability to turn that part,
the part will actually grind on the cross slide or the like the carriage of the lathe. The part will grind on it if you don't turn it down in small, like 10 millimeter steps. So, like, it turns out to just add a whole lot of time to making each part by working on this little thing. But same story as the other stuff. We turned the outside first, then turned the inside, and then finally turned the taper. And as I went through the part, it got really hot. The aluminum absorbs a whole lot of heat, and I don't think I had my tool set up correctly, so there's a decent amount of rubbing going on. I tossed a couple of ice cubes in there from time to time to cool it down. Is this good for the metal? Probably not. Did it work well enough? Yeah. This is why we do test motors, right? This is where we learn things. Anyway, once the internal taper was cut, it was time to turn the grooves for the O-rings. So there are 2 grooves here for these very large-sized O-rings. I am pretty sure this is correct, but basically the larger the O-ring, the bigger the squish factor, or at least the more generous the tolerances are. So if we have a case that's slightly out of tolerance or we don't turn the O-ring grooves totally correctly, it should be easier for us to get away with that with a big O-ring than with a small one. Someone please tell me if I'm wrong on that. Turning the grooves was a learning experience. I tried a couple of different lathe tools before I found out that just using a parting tool and a slotting tool was the way to go for this, and you get a better surface finish on that anyway. Yeah, learning lots along the way. Finally, I attached some test O-rings and I put it into the test case, and it fits. Against all odds, it turns out that I have designed something that works kind of on the first try. Now, obviously, we haven't tested the pressure inside of this motor. We don't know if they actually seal, but the fit was consistent with, like, this is a good seal and requires the O-ring to squish a little bit, which gives me confidence that I think we have a good seal here. Okay, next up, I took the graphite throat and the phenolic piece, and I had to attach them together. So we do this using something called RTV, which stands for room temperature vulcanized, or something like that. It's a weird acronym, but basically it's this high temperature silicone that helps seal. It's like a gasket maker. You want to create a gas seal, and then the high temperature resistance helps a lot when it's in a nozzle. The one downside of this is that it requires air to cure, and I haven't figured out a way around this. It should still seal, and everything is in compression, so like it should still be all above board, but basically it is for the most part, and it doesn't actually need to cure all the way for it to be fine. I maybe talked about this already, but the other thing you can do is you can like wipe the parts down with a little bit of oh no, that's Elmer's glue all. That you use water for that. Anyway, yeah, I just like let it sit out for 30 minutes before I push anything together, so it has like a little bit of time to start the curing process. Basically, when you coat the whole thing in this RTV and then you insert it into the phenolic part, the middle of this joint is maybe never going to cure because it isn't exposed to humidity and it isn't exposed to air. It can't like off gas or anything like that. There's nowhere for the gas to go. So I don't know what to do to solve this. There are some 2-part RTVs that I tried, but they had really bad surface adhesion. I don't know. This is sort of a work in progress. The fit between these 2 parts wasn't perfect, and I ended up turning down the nozzle later. We might talk about that next week. I have the graphite throat seated into the phenolic part, and with that drying, it was time to move on to the forward closure. So this is a much simpler part to make because it's just one big slug of aluminum, but it also is a more complicated part to make because it's one big slug of aluminum. So it's a bigger piece to work with. It's harder for the lathe to turn it. And so the process goes something like this. Basically, first I had to put it on the mill and cut out a little centering like divot in the part because the chuck that I have on the lathe isn't big enough to grab the 6-inch diameter
this was an awful process.
And so we make this little hole in the mill, then we mount it on the lathe, and we start turning down the outside diameter because same thing as before, the lathe cannot actually travel all the way across the part until you turn the diameter down enough so that the carriage can slip under the part. Once those things were done, I took a bunch of passes to turn the part to the final largest outside diameter and tried to get the surface finish just a little bit nicer. Then I cut the O-ring groove for the liner. We sealed the liner up at the top with this forward closure, and that's to try to prevent gas from escaping and going around down through the side of the case. I tossed an O-ring on, and the fit with the liner material seemed pretty good. Seemed like it was going to seal well enough, so we moved on. The next two O-rings are the same as the ones that we turned on the nozzle part. These are here to seal as a primary and backup for the case pressure. And these are critical seals. One thing I've learned so far is that I don't think you really need the backup. As long as you're doing okay with machining, like, you don't really need the backup O-ring. I mean, like, you have to be doing good machining, but the backup seems to be a little overkill on this stuff. Cannot fail. The liner one can fail a little bit. It's all right if it's not perfect, but these ones can't. Turning these was a lot easier than on the nozzle because I knew the way that I wanted to do it from the start, which is a good segue into talking about how building future motors is going to be much faster and probably much easier because I've figured out a lot of the things that I want to do differently to speed things up as we go forward. After turning those O-ring grooves, I bored out a hole through the center of the part with the intention of turning down the rest of the part on the lathe. But as I kept going, I kept having problems with the boring bar just singing me the song of its people. It was really loud. It was taking a lot of work. And the lathe was like screaming the whole way along. So then I had an idea. I tossed it back on the Tormach mill. I tried really hard to center the part very well so that we didn't have concentricity issues. And then I milled out the rest of the part with the Tormach. The other benefit here is that because this is the pro gamer move, by the way. This is how we'll do a lot of the future rocket motor stuff, is the Tormach is going to eat through a lot of the material while I focus on other tasks instead of just using a manual lathe. And when I do use a manual lathe, it'll be the Precision Matthews that I have now, which has crazy torque. It's, like 220 volt. It's like big torque boy. So it can eat through metal much faster than the eBay lathe. Like, each one of these parts, like the forward closure took 4 days to do, and the nozzle took like a week and a half to do. And I expect both of those things to drop to like a day with the Tormach and with the Precision Matthews. The Tormach is an automated machine. I can count on those tolerances being pretty good, and I can also let the machine do its thing and just periodically check in as opposed to babysitting the machine the whole time. Removing this much material was a tricky thing to do, especially with the sketchy blue tape and CA glue mounting method that I had.
Shout out blue tape.
But it did work. It failed once. It did actually fall off once, so there are a couple of nicks out of the forward closure, but not in any parts that should cause big problems. But the material removal was crazy. The number of chips we've generated is like wild. But anyway, this is the finished forward closure with some test O-rings on it. It feels pretty good. It looks pretty good. Now, it's not totally finished. I guess that's a lie. I still have to tap the center hole for the HEI bolt. That's head end ignition. I have to drill and tap the holes for the 3 pressure transducer ports that I want to have up here to measure the pressure in the motor as the motor is firing. And then we have to drill the radial bolts through the case and through the forward closure. So right now on the printer, I've got a big old print guide or a big old drill guide that is going to help us make those holes. And that, again, this is a thing that can happen on the Tormach in the future. At least for 6-inch motors, I'm kind of thinking of going to 8-inch, and I am a little worried that the Tormach won't be able to do that. But we'll see. We'll see. That is what's coming up in the next 2 weeks. So we have to get those holes made. We have to get the HEI bolt made, turned down the lathe. We have to get the HEI chemicals into the form that they need to be in a safe way. We have to cut down the motor a little bit to get it to fit in the case. There's a bunch of little things that we're just like marching on forward to the static fire with. I'm not very good with my words today, but basically, there's still some work to go. I probably need at least 2 more weeks until we have a finished looking and feeling motor. And then I need to build a test stand, which is maybe a week and a half task. And then after that, we can fire it. So we're really getting there. I didn't expect it to take this long, but I'm learning a lot along the way, and it's going to be shorter in the future. Anyway, thank you very much for your support. Thanks for sticking around during this long video, and I will see you all in 2 weeks. May your skies be blue and your winds be low. Boom. There we go. Okay. Fun little video. Thanks for hanging out, everybody. Now we can just chat for a little bit. What is up, Teeth? Thank you for the super chat, the €2 super chat. Joe
Banard. Thank you. Insightful. Yeah, how's everyone doing? We can talk a little bit about Simplex if you want. We could also talk about whatever else. I figure, like, every 2 weeks we'll toss one of these videos up, just watch it, and then we can just chat for a minute. Yeah, I can, like, take some questions. I'm burping a lot because of the Dr. Pepper. All right. What are we doing? Are you going to publish another fail compilation video? Maybe. The high power fails aren't as interesting because you don't see it hit the ground most of the time. They're not quite as nice. I'm making my own flight computer. Can't figure out how to check if there's continuity on a pirate channel. Can you tell me how you are doing it on Ava? Ooh. How am I doing it? Wow, I can't remember. It has been a minute since I did any of the electronic stuff. I mean, I think it's just a voltage divider. Let me make sure. Actually, I can just pull it up. Yeah, I'll just pull it up. 1 second here. Yeah, I think it's just a voltage divider. So you send the battery power through, but you push it first through like a 1 mega ohm resistor. Oh boy. Yeah, so how does this work? The power comes in, it goes to the terminal. As it comes out of the terminal, we're switching the ground side of the pirate channel. And there are... Okay, that's not the continuity, though. Oh, that's the wrong channel. Yeah, okay, so it comes out of the pirate channel. It goes into a 100K ohm resistor. Then it goes into a 27K ohm resistor. And between those two, you stick a sense line, like an analog input on your microcontroller. So this is it's just called a voltage divider. If you look it up, there's a way to do the math on it, or like, you can find little online calculators. Yeah, and the voltage divider lets you measure whether there's like current flowing through the line, but do it in a way that's easy, and like, especially given that first high resistance resistor, you can do it in a way where you're only sending microamps of current through the igniter, which is what you want, because otherwise you fire it. Okay, I have a question. After you launch a rocket into space, do you end up with rockets, or do you still have some plans? I will still do rockets after. You've been a great inspiration to me. I've been watching all your videos since the first attempt at VTVL with Relay 1. Wow, shout out. That's a long time ago. I want to thank you for motivating me. Thank you. That's very nice. We ball. That is true, Miranda. We do. Can you give me your blessing on pre-calc? I passed that in Calc 1. What do you me the honor of blessing Calc 2? Oh, would you do me the honor of blessing? Yes. Blessings upon you and your Calc 2 exam. When Simplex V2? I don't know. I think Simplex V2 might just be flying. We'll see. It's a little bit up in the air right now. Show RIP EB Debris. EB Debris is in pieces in the back room, and I'm not going to show it just because there's a whole bunch of parachute lines attached, so it's hard to carry it. But yeah, EB Debris is it is in some pieces. It keeps flying though. It keeps getting into pieces, and then I keep building it again. So it's hardy. The little starship is dope, and it's not just a model. It's a butane torch. You use it to light the candles. You take the little thing off. You can fill it with butane. Pretty sick. What is the benefit of bonding grains into liners? Some of the motors you've shown, you bond the grains into liners, and some you don't. I think it's in general, it's better to bond the grains into liners. It's especially for like high G stuff. It's a little better like structurally. I think it can slightly, I'm probably not the person to ask for this, but I'd tell you that like, when in doubt, just bond it into the liner. When in doubt, it is better to bond it into the liner because you don't want that face to burn. Can you wait? Hold on. Do you already know when a new video is coming out? Yes. Maybe next week. Probably not. Probably the week after.
Could you talk a bit about that motor disposal gone wild? The video of the rocket motor flying around is insane. Yeah, there's not too much to talk about. I can show you it if you want. One sec. All right. Here it is. See if I can zoom in. I think this punches it in. So this is the motor. It was, it says HGRK1, so it was for the hot glue rocket. This is the nozzle, and this is where the forward closure was. Here's the forward closure. And what happened, if you can look close, there's actually still part of the composite case on this. So the forward closure gets bonded in with epoxy, and it just overpressurized. I mean, the case is designed for maybe 800 PSI, maybe 1,000. And we definitely went above that just because the propellant that I had poured in there had really, really fine 90 micron AP, and also there was a soft uncured section in there. And so, yeah, we burned really, really hard. We popped the forward closure out, and it flew around quite a bit in a, somewhat chaotic way. Let me put this on the floor. All right. I heard you. Oh, and then Paul says, I was surprised it burned so long. Right. So the reason it burned so long, right, is because the pressure inside the motor, as soon as I blew out the forward closure, the pressure in the motor is almost atmospheric. It's probably like 80 PSI in there at max. And so, of course, it's going to burn long and have a really low thrust because the pressure is really low. Dude, the thumbs up thing is so sensitive. We can do a little confetti, too, if it'll recognize it. Yay! All right. I heard you don't like hybrid rockets. What is their disadvantage? Because I want to build one soon. I mean, build one if you want. They are inherently unstable. It's extremely hard to model them accurately. You need a lot of test burns in order to do that. And I just think it's fun to hate on some stuff and just pick something to hate. I don't know. I'm a hater at heart. What happened with the VTVL rocket model project of the Starship? It is perpetually on the back burner. I only have so much time, and I would much rather work on the space shot than I would on the Starship. It would get more views, probably, but I don't know. Chasing views is not a thing that tends to lead to a lot of joy. Let's see. What's your RF plan for the space shot? Just bump the wattage up. That's it. Bump the wattage up, bump the data rate down, and that's how we'll compensate for it. It'll still be the RFD 900, as far as I can tell. We might put a computer on there or a radio that does 400 megahertz just in case. But yeah, the plan is bump the wattage up, bump the data rate down, and just like every few seconds blast out a big old block of all the sensors and like what it's doing. Is this live now, or is this live now, or is it just the live that was recorded last year? There's no live recorded last year. This was a video that was recorded last year, and I am live right now. It is currently February 21st of 2024. What's that hexagon tile for? Is there a hexagon tile? Oh, this thing! This is my buddy Winston Moy. This is his logo. Let's see if I can get a little close-up on it. This is his logo, Winston Moy. You should look him up. He's on YouTube. He's a machinist, and he made these little isogrid coasters. They're beautiful. They're so well done. That's what it is. Have you ever thought of landing a rocket from higher height than Scout? Yes, I have. Can you say where to source BP for ejection charges legally? I can't find any viable way to purchase it. Looking to do dual deploy soon. I've purchased it online before. If you poke around a little bit, you can find sources online. Honestly, like Bass Pro Shops, if you're in the U.S., it's not too hard to find BP legally. If you're outside of the U.S., it is harder. I don't really know what to say other than like the U.K. has done some terrible things for hindering amateur rocketry. Do you know any rocket test sites in Europe? I do not. I am sorry, Nico. Love your videos and your tweets. Thank you. Thanks, Paul. Thank you very much. When cooking with Joey B? I don't know. How much have you paid the CNC? Man, the grammar in some of these is crazy, dude. How much have you paid the CNC? I don't know what that means. I have not paid my CNC. It remains in my garage, and I have not paid it.
I did get the Tormach. I did get for free as part of a sponsorship deal from Tormach. So the CNC was sent to my house, and then I made a video for Tormach about my experience with them, and then also like intentionally show it in a bunch of BPS videos. So that's sort of how that works. Can you explain the spin casting of the liner? What kind of material would you use? Yes, I can. So when you have a linen phenolic liner like we did for Simplex, you have to make sure it fits inside the case, right? If it doesn't fit inside the case, you have to turn it down on the lathe. It's a whole annoying process. And so instead of doing that, you could also just spin cast a liner, which means you create a liner like a liquid substance, and you do the same thing that you would do with propellant. You mix all the liquids together. You get, hi Cam. You get all the liquids together, you get all the substance of the liner together, and then you pour a curative in, and really fast, you bring it over to a lathe, and you start spinning the crap out of it. And when you spin it a ton, the like internal G's that the liquid feels makes it coat the inside of the motor case evenly, or ideally evenly at least. It has to flow pretty well for that to happen. And so that's the goal, is we'll spin cast liners. Now, there's a ton of ways, there's like a ton of ingredients that you can put in there. Some people do liners where it's not totally spin cast and they use like an EPDM insulator. Some people use phenolic microballoons. There's another thing called thermocells, which is like a ceramic microsphere. That's an insulating additive. Kevlar is another common component, like Kevlar pulp does pretty well. It also helps the structure of the liner a little bit. HTPB is usually a part of it, or if you're doing older stuff, it's PBAN. Yeah, and there's a couple of ways to do it. It depends a little bit on how flowable you need it to be. Okay, moving on. I have to speed up a little bit here. Is this live now? Yes, it is. I've been following since the Sprite days. I remember watching the Sprint 1 kilometer launch on live stream, and it was so cool. I got the same jitters I got watching Orbital launch. Keep up the great work. Thanks, Alex. Alec. Sorry, not Alex. Alec. Thank you very much. Yeah, that was a nerve-wracking launch. That was like as high as I had flown. I would love to do more sprint flights. I'm kind of trying to get the same energy with EBDB right now. Our goal is to like fly every 2 weeks, learn a little bit every time. Do you check whether there's a short circuit in your pyrocharge like the wires touching? I don't actively check for that. I just check for continuity, and then checking for short circuit is mostly just do good wiring. Why are you so harsh on hybrids? Oh God, do we have to keep doing this? Hybrids suck. They're bad. They're inherently unstable. You cannot properly model them. They scream. Like a lot of the hybrids I have seen scream when they fire because there's such high frequency in like combustion instability. Yeah, and it's like, if you're going to be a bear, be a grizzly. If you're going to use liquids on your rocket, go buy propellant. Let's see. For an amateur builder, would you recommend solid or liquid fueled engines? Solid, probably, but that there's not nearly enough details in the question it's like, it depends on your goals. You know, if you want to build a hopper, don't build a solid. If you want to build like a I don't know. It depends on your goals. Water jet cutting. You gotta, okay, new rule. You have got to ask relevant questions that make sense. What does water jet cutting mean? That's not a question. Sorry to be frustrated, but like, come on. Okay. I'm going to stop answering questions that don't make sense. How much latency is there on the live? Because you seem a bit behind. Yes, I am a bit behind. Would you be interested in coming to the Spaceport America Cup? Probably not this year. Maybe next year. I'm not flying anything, and it's quite a lot to drive or fly out if I'm not flying anything. But I'm always at FAR if you're out there. Will the space shot go so high that the rocket will re-enter the atmosphere, and will you work on heat shield development? It will re-enter the atmosphere. but it will not have the speed that you typically see from like an orbital capsule or a capsule coming back from the moon. So we don't need to think about heat shields that much. We need to think about it a little bit, and it's more on the way up because we're doing like Mach 4, Mach 5 on the way up, and that is where the heat problem is. So we'll have maybe some ablative or a lot of metal on the nose cone. All right, we're going to skip some of these. If we are still rolling with the 3D animation, I don't know what that means. I have a couple of folks working on a 3D animation for the EB Debris flight that I just recently did. And if you support on Patreon, you know what I'm talking about. Yes, Ryan has not done the render of EB Debris yet, but there are a couple other folks too. Is air launch ever going to happen? I don't know. How do you afford these rockets, especially the space shot motors? Patreon. This is it. Not to keep harping on it, but people donate every month, $5-10, and because of their generosity, I'm able to fund this stuff. It's not just Patreon though. So there's Patreon, there's YouTube ad revenue. So when I make a video that does really well, the ad revenue on that video helps pay for components and bills and things like that. And then there are sponsorships too. So it's kind of three big things. It's the YouTube ad revenue, sponsorships, which is when I'm like, oh, this video is sponsored by Brilliant or KiwiCo or something like that. And then there's the Patreon. And the Patreon is the most stable of all of those that like really helps me budget. So looking forward 1 to 2 years, I can plan out, okay, we can probably move at this pace and have this expenditure rate and not be in a bad situation. So that's the biggest one is the Patreon, or like the biggest thing I can count on, basically. All right. Oh boy, I'm getting really behind. Sorry, folks. Thank you, Alan. Your videos are really nice and informative. Cute. Kudos, Joe. Yeah, thank you very much, Alan. I love the music in your video. Do you plan to put it on Spotify? Yes, I am trying to get in touch with a music licensing agency. It's not going great, but I'm trying. We're working on it. You started this project to gain enough experience to work at an aerospace company. Has anything like that been offered to you to this day? Yes, it has. It has worked. I have indeed, no, you don't get direct job offers. I think that's like a kind of misconception. Like no one shows up and is like, wow, I saw your YouTube video. Do you want to work here? And here's a salary offer. Like that never happens. What does happen though, is people say, oh, this is interesting. Would you like to apply for this job? Would you be interested in interviewing or that kind of thing? And so like, I've never gotten a job offer from it, or not a legitimate job offer, but you do, like I went through a couple of interviews at SpaceX a few years ago. I went through an interview at Firefly a few years ago. And yeah, no, it turns out putting your stuff online is a pretty good way to, or at least just documenting the projects you do online is a pretty good way to make sure that companies see that you are self-motivated, you're able to teach yourself stuff, you're able to keep, guide yourself. And that's a really valuable thing that companies look for. Like, it sets you apart from just having a good degree. Will you test risky Batman using smaller engines on smaller rockets? Probably not. We're probably just going to make some big stuff. Do you like Cool Whip? I don't really know. What diameter can the eBay lathe handle? 6 inches. Solid. Oh my gosh. I'm sorry. I'm having trouble reading. I don't know how to read, so it does make it difficult. Do you think that with your knowledge, you wouldn't be able to work in NASA or SpaceX? I don't think the question makes sense. You can work lots of different places with lots of different amounts of knowledge. How do you compensate for accelerometer? Here we go. Here's a good question. How do you compensate for accelerometer error when doing dead reckoning? Oh my God, the thumbs up. Before transforming into the global frame. So, okay, Nerdtronaut, great question. When you're trying to do dead reckoning, it means you're integrating the accelerations. You're adding the accelerations up over time to try and estimate your velocity and maybe your position too. So you can use your accelerometer to do that, but you can't, your accelerometer, there's an accelerometer on here, right? And as the vehicle rotates, So does the accelerometer. So like this is, let's say this is your x-axis. As the vehicle rotates, your x-axis is now pointed this way. But what if you want to track where it is in like the global space? You have to make sure that your accelerometer is tracked through the rotation so that this is still the x-axis no matter what the orientation of the computer is. And we call this a frame transformation or a reference frame transformation or just generally different reference frames. So like the global frame, if you're standing on the ground watching the rocket, you're kind of watching it from an inertial frame or a ground frame. And then we call the frame that stays with the rocket, the one where the x-axis is always looking this way, this is sometimes called the center frame or the body frame. Transforming between those is a thing that quaternions make really easy, but you can also do it with direction cosine matrices or Euler angles. And transforming between those is like the big thing that is, I think, very, very hard for people starting to do TVC because they don't know it's a problem they have to solve until they get there and they realize like, oh shit, this is actually very hard to do if you don't know how to start. But yeah, that's a frame transformation, and then you have to calibrate your accelerometers if you want to do dead reckoning. You don't have to, but you'll get much better results if you calibrate them beforehand. And that mostly looks like using external references for what is straight up and down, and then calibrating to exactly like 9.81 meters per second squared of gravity. Excuse me. The Dr. Pepper is really doing a number on me. Which is funny because I keep drinking it. All right, moving on. How's Ava's Kalman filter these days? It's pretty good. It's not great. A lot of edge cases. Yo, Cool Whip Man, if you keep asking, I'm just going to ban you from the channel. The Kalman filter's okay. There's a lot of weird rogue GPS stuff that happens. Do you have any plans to refine your antenna design and placement? Oh, what's up, Kyle? To improve the gain, external patch fin. Yeah, so for telemetry, it would be nice to fly with patch antennas, especially when we start doing these big metal motor cases. Yeah, I don't have any active plans for it. I do think it's a reality that like I'll probably have to do something like that. Do you have any plan? Okay, yes, I read that. I'm so far behind. Ever thought about a CubeSat or something similar? Not really right now. Can you give a ballpark cost numbers on sizes, project complexity for amateur rockets? I can't give a ballpark estimate without more specifics, really. Yeah, it totally depends on the size of the rocket. All right. Let's see. I'm going to scroll down a little bit. Any idea what you want to do after the space shot? Big scout? Maybe. I mean, honestly, after the space shot, I'm probably mostly going to want to take a nap. That's my plan so far. Do you do an all-up RF antenna integration test when the rocket is assembled in its flight configuration so that the antenna reflection off other components of the rocket is taken into account? Yes, Chris. Good question. That's called integrated testing. So you put together the rocket, you put together all the antennas, you set up a telemetry ground station, and ideally you have some type of rail that you can put it next to so that you simulate as much as possible what will happen on the launch pad. Integrated testing is like the thing that solves the most issues on my rockets. So a couple of days before launch, you stand this thing up in the configuration that it's going to launch in. Whether the motor's in there or not usually doesn't matter too much. But you stand this thing up like fully integrated, and then you get out the telemetry radio, you see if it gets GPS satellites, you see what your RSSI is or your signal strength is, and yeah, over the course of like doing that, taking the rocket down, moving antennas around, putting it back up, that's like the number one thing that solves a lot of issues for me. So I definitely do all-up testing with RF equipment. How does your accelerometer bias calculation work? I am probably going to be making some of this up. I can't remember how. So you can do one of two things with your accelerometer. You can assume that you're upright. So we do this for Scout. So for Scout, I leveled it manually on the pad. I got like this really nice laser precision level, and I would
actually level the rocket manually on the pad. I had these 4 screws around the pad base that I could they're jack screws. They could go up or down. And so we would put the rocket on the pad. We would sit it just flat. And while it was there, I basically knew, like, when it's sitting on that thing, you basically know as long as it's level by the external thing, we can do whatever we want in the software to calibrate the accelerometers to reflect that. So the accelerometers would be maybe reading, let's say, 3 degrees pitched over or something like that on the pad without calibration. And so you can just force it to 0. You create whatever offsets you need to force that orientation to 0. And that's kind of how you do it. Trying to think of any other details I can provide on that. I think there's like a little bit of trig, like you have to use arctangent or something like that to get the attitude from the accelerometers. But like that part's pretty trivial. the stupid thumbs up. That part's pretty trivial. But for calibration like that, you can either actually ensure that the rocket is truly upright and then force it upright in the software, or you have to go through a calibration routine that's very similar, but you have to store it in the flash or something like that, and then count on your accelerometer still being in the right alignment, and that part is a little bit more tricky. Okay, instead of using heavy metals on the way up, have you ever thought of using a starlight material that is lighter and more efficient than SpaceX or NASA's heat shield on tiles? I have not thought of that. Do you have any experience machining steel? Yes, I turned a stainless steel nose cone. I turned a stainless steel nose tip on the lathe in August, and I hated it. It was awful. I do not like machining stainless. They say anyone can machine aluminum, and they are right, because aluminum is very easy to machine, and stainless is not. Do you think a moving average filter is accurate enough for propulsive landing? No, but it depends on what you're talking about. There's not enough details in the question. Like, depends what you're filtering, but largely no. What's the time plan of your upload right now? I have no time plan. The video comes out when it's done, but ideally 2 weeks. How's your CFD going for roll control? Can't wait to see a video on your roll tab system. It's done! The CFD is done for roll control. If you're on the Patreon, you know that. I just put out a video yesterday all about all of the validation stuff that we did. The roll control worked in flight. It's done. We kind of nailed it. It's very exciting. There's a lot of CFD. So there will be a video on that. Is there anything you can recommend to learn the software stuff that I'd need for a flight computer? Kalman filter, quaternions, etc. Yeah. I mean, I would just say start building. Start building it. Try. It's a frustrating answer to hear. I know that. But just start. Like, get an Arduino kit, get some sensors, see if you can figure out how to get orientation from a flight computer, and get comfy with hitting walls, like bumping into roadblocks, and then figuring out how to redirect yourself after that. That is the way that I did it, and I think that's the fastest way you can do it, because if you're just trying to start from theory of like thinking through the process, you won't retain as much of that knowledge as you will if you're actually putting it into practice. Dr. Pepper stands. That's true, Adam. Shout out Dr. Pepper. This video is sponsored. It's kind of sponsored by the patrons, I guess, but in a way, it's also kind of sponsored by Dr. Pepper, because I'm sure at some point some of the money from Patreon has gone toward purchasing Dr. Peppers. In a way, we're all sponsored by Dr. Pepper, really. Okay, let's see. Just relaunched my university's rocket team that died. Any projects that really challenged you and helped you learn a lot? Ooh, yeah. Sprite, the hopper, the EDF hopper, learned a ton through that project. I wish it hadn't melted. I would fly it again. But yeah, Sprite was a great project. Learned a ton, and it was really safe to like develop with. Now, granted, like, you know, you can chop your fingers off pretty easy with an EDF, but I'm talking about like with university teams, it can be very hard to do rockets sometimes. You know, colleges are like rightfully so a little bit wary of explosives or propellant chemicals and things like that. So I think Sprite was a really good exercise in control systems, flight software, a little bit of mechanics, mechatronics. You have moving parts. There's a LiDAR on it. There's GPS. There's all sorts of really great things that you can learn through a project like that.
Are you going to make a series out of the risky Batman videos like Simplex? Is it more than 2 vids? It's probably not more than 2 vids. The next video is going to be about CFD. Those 2 videos are probably most of the propellant stuff that I'll talk about. There's quite a lot that gets left out of those videos intentionally. Like, I don't think that anything I shared was close to being ITAR controlled. But like, there's some stuff about big solid rocket motors that I don't want to push out online. Yeah. I'm working on a rover project. I want to drop it off a building or weather balloon. Can I have some suggestions on how to determine dimensions for your builds and shoot dimensions? Again, I don't feel like I have enough details in the question, so I can't really answer it. Those are, yeah, I mean, that sounds like a thing that you define for your own project. Do you enjoy playing Kerbal Space Program? You're an excellent role model. Thank you, Stuart. I do. I haven't played KSP in a long time. I used to do a bunch of KSP streams. I should bring those back. Those are fun. I like KSP. Can I ask about a project that you had with Charlie Garcia in 2020? Only patrons know about this. That's right, Lewis. It was called Absolution. And the goal, I guess I can just be public with it now, but the goal was to do a monopropellant model of Falcon 9 with a propellant chemical called ATU-12, which you will not find online. But yeah, and then, I mean, the thing that happened with it was mostly just that, like, Charlie has a real job building Moonlander engines, and I have a job building YouTube channel videos, and it's very hard to build a hardware project if you're not in the same place. What frequency bands do you use for telemetry and other communication? 915 megahertz for most stuff, sometimes 400 or 433 or whatever you want to call it. You can turn off the thumbs up by clicking the camera logo on your menu bar and then clicking the reactions to disable. Yeah, Mark, I could, but it's kind of funny. It's kind of funny for me to just be like this, and then like it happens to come up. Is it gonna do it? Is it gonna do it? I think it's funny when it happens to come up. Okay, gonna scroll down a little bit. Stainless needs a lot of rigidity and spring passes. Yep, Adam. Yes, it does. Yes, it does. Have you ever looked into PLC systems for your rockets, like the bigger ones? Not really. I don't think I've really had a need for that. Are you going to put fins to control the space shot rocket? Yes, I'm trying. It is going surprisingly well so far, so it's looking like yes. Will you have any other formulas beside Risky Batman for the space shot? I don't think so. I think we'll stick with Risky Batman. It's good enough. It would be better to have multiple formulas and have like formulas that are tuned and whatever, but like better. I cut a big part of the last video out where I talk about this. Better is not actually like a great word in engineering, because better changes depending on who you are, the materials you are allowed to be working with, the materials that you have access to, the people around you, the projects you've done in the past, your monetary constraints, your physical constraints, your timeline constraints, and all sorts of other things. So like, for me, I am very uninterested in continuing to do more propellant development. I know I can make it work with Risky Batman, so we're just gonna say problem solved, next problem. How do you use quaternions? Are your set points also quaternions? How do you use quaternions is not a question I can answer concisely. I can answer questions that have like non-open ends, and my set points are not quaternions. I only use them to track attitude, and then I convert right back to Euler. How about cost for Sprite or similar, but maybe a smaller vehicle? I don't have a lot of good numbers for you off the top of my head. I would say $1,000 maybe, between batteries, a nice fan, the carbon fiber struts. The printing stuff doesn't cost much. The servos cost a bit. Flight computer cost a bit. Depending on if you want telemetry, that costs a bit. Maybe $1,000, maybe a little less. What kind of microcontroller setup would you recommend for a flight computer capable of all the sensor fusion stuff, including GNSS? I don't know. Teensy 4s are pretty great. They've got like a lot of overhead. It's like 600 megahertz, right? Would you try to put a gimbal on an EDF? Would it be a good idea to try gimbal and EDF on and sprite-like vehicle? I don't know. Depends if you want to. In that video you made with the motherboard channel, in the comments, many believe you are a clone of Elon Musk. Great, thank you. What would you say are the greatest hurdles when doing fin control? Characterizing the forces. Right, yeah. Okay, so Jacob, good question. Also, hi, Jacob. What's up? Yeah, I mean, I think the biggest hurdle with fin control, at least my biggest thing that I was scared about, was characterizing the forces. You've correctly identified there. There's the thumbs up again. Yeah, the biggest thing for me was like, I don't actually know what forces are coming out of a given deflection at a given speed at a given air pressure. And so honestly, I just brute forced it. I ran 1,000 different SolidWorks CFD sims over the course of 2 months, and I compiled a big table of data. And like that still came with a ton of uncertainty, because CFD is really like, the quality of those simulations are all about the user. They're not about the program. You can get good results from SolidWorks while getting terrible results from ANSYS if there are 2 different users. And I experienced that. But yeah, I think the biggest thing was learning how to do CFD in a way that gave me results I was confident in. And then building the controller around it was not that hard. It just required a little bit of creative like curve fitting. And it seems to work pretty well so far. I only have like 20 seconds of good controlled data. But like during those 20 seconds, it's pretty good. Do you ever feel constrained by the performance characteristics of the processors on Ava? Thermals, clock speed? Yeah, good question, Keith. Not right now. Not right now. For all the stuff that I need to be doing, I don't feel that constrained by it. Thermals, certainly not. Ava doesn't really have thermal problems. Clock speed, maybe. Going with 3 separate processors was kind of stupid. Like, I'm glad I did it, but going multi-core might be nice if you were going to do it today. Passing data between the flight computers takes a bummer of an amount of time. So let's see. I'm going to skip some of these things. What types of things are you not allowed to say about solid rockets? Well, I couldn't tell you. I couldn't tell you. If I told you, I'd have to kill you. No, I'm mostly kidding. I mean, there's just specific stuff about techniques for mixing. There's stuff. None of this stuff is a hard black and white thing. But what I don't want to do is show up on the internet and tell you exactly every single step that you need to know in order to make a solid rocket motor. I say it in every video, but like, they are not tutorials. If you only look at my videos, you do not know enough to be building solid rocket motors. And so it might look complete, and it might be a satisfying story, but I leave out quite a bit, and kind of intentionally, in order to make it so that like some kid who doesn't know what he's doing, like doesn't go buy a bunch of chemicals and get himself hurt. Can you explain the code architecture behind the sine wave maneuver on Scout E? Wow, deep cut. Ooh, I can't explain it off the top of my head, but I probably have covered it in the engineering cut for Scout E. If you look up that on the BPS Space channel, I bet it's there. Great question. Holy Moses. Yeah, because I would generate a sine wave and follow the sine wave on Scout. That's such a throwback. Wow. Yeah, I bet it's in the engineering cut, and I bet I explain it much better than I can right now. Okay, thoughts on operating a second ground station a couple miles away for high-altitude flights? 2 thumbs up, Kyle. Big 2 thumbs up. Huge fan of that. Having an away team, both for video, like a video away team is great because it's easier to track the rocket that way than when you're right under it. And for telemetry, if you just think about like the geometry of it too, and I assume this is what you're asking, but like if you have a rocket with a... Okay, hold on. It's going to make sense in a second. Oh, God. All right, well, let's just do this. Okay, check me out. This is a rocket. This is my Aqua 4 rocket, right? This is a telemetry antenna on top of the rocket. So see how the telemetry antenna is pretty thin? Let's just pretend it's not a penny, it's just a stick. The telemetry antenna is pretty thin. As you go higher and higher up, eventually the rocket is going to occlude the telemetry antenna, and you won't, if you're directly below the rocket, the telemetry antenna is not going to be visible from the ground. You're just going to be looking directly up the butt of the rocket. And so by having an away team, if your rocket is here, this is so stupid. Okay, imagine the antenna in the same place. If your rocket is here and you're right here, you're not going to be able to see that signal very well because you have to go over the top of the rocket. But if you have an away team, that's a much easier path for the signal to take. So I'm a big fan of it. I haven't really done it much yet, but I think for really high stakes flights, great idea to have a ground station that's like remote. Okay. You should buy a Reliant rod. Are you still pursuing your plan with the rotating camera mount? No, I am not. My plan now is controlling the whole vehicle. How much did the L3 cert cost? Either time, Lumineer or Send It. Lumineer was very expensive because I bought a lot of stuff to like tools in addition, and I spent, I think, a couple $1,000s because again, like I was buying tools, I bought saws, drill presses, a ton of fiberglass components. Like a ton of fiberglass building components. I can't remember what else. I bought a bunch of like live video equipment because I wanted to live stream video from the rocket. It was way too ambitious. And then Send It was not that much money. Send It was, what is the cost of the motor? I think maybe $500. That can't be right. I don't know. Cost of the motor, and then I would add an extra $400 for the fiberglass components it needed. And it also used the fin can from Lumineer, and that helped with cost. Do you use Jira or some other project management system to track your own projects? Is it just anarchy? It's not quite anarchy, but it's not Jira. I have a lot of notes on my phone about like what needs to be done, and I block out days on the calendar for anticipated like drop dead dates and stuff like that. Okay, skipping some stuff. Trim tab roll control was really impressive. Thanks, Chris. I'm going to do a video on it soon. Let's see. Are you still planning to make Ava open source in the future? Is there a legal reason why or just personal stuff? I'm not planning to make Ava open source. I keep thinking of selling it as like a programmable thing, but I don't know. I'm not like interested in producing 1,000 of these things. They're quite a lot of work to bring online. I don't have any plans for it right now. The one caveat to CFD program versus user being that if the program doesn't allow you sufficient resolution or detail in the sim, you cannot get effective results. That is true. Ever considered an FPGA for the flight controller? No, I have not, but not because it's not a good idea, just because I have a controller that works already. Do you have a plan for a more integrated thermal management system for the cameras versus just an aluminum heatsink? Nope. Love the heatsink. For now, it seems like I'll just add more aluminum as I need it. What will you change to improve the nozzle design from Simplex, and what's the biggest problem you've had with larger motors? I can't really answer the second one because I haven't built a lot of larger motors yet, but the biggest problem with the nozzle design for Simplex was just the number of tapers for machining. On larger motors, I will want to still have tapers, but not quite as long. We'll do sharper tapers, basically. Is it necessary to have multiple cores controllers, not in terms of processing, but rather timing? I think it's necessary below a certain processing speed. So like the Teensy 4.0 might be able to do it because the clock speed is so fast. For Ava, the clock speeds are slow enough that especially for like the Kalman filter really needs to like have its own thing. Because at some point, it can take up to 10 milliseconds, up to 20 milliseconds, depending on what data you're feeding into the Kalman filter for it to actually run through all the matrix math that it needs to do. And if you're trying to run a Kalman filter at 100 hertz, like a 10 millisecond runtime means you're completely saturating all of your clock cycles, 100%. So then you don't have clock cycles for telemetry, for data logging, for actual like TVC, fin control. You don't have clock cycles for all sorts of functions that you need on a flight computer. So maybe going up to a higher processing speed fixes it where you don't need multiple cores. How does the lookup for the fin control work? Is it a deflection to force mapping 1-to-1? If not, how do you deal with that? Paul, that is a good question. It's a 2 or 3 step process, and I think I'll talk about this in the video. The controller, the PID, demands a torque on the vehicle. And then we know the moment arm, so we know how far away the tab is from the center axis. So we convert that torque that the controller demands, we convert that to a force. We divide by the moment arm, we get rid of the moment arm, and now we just have a side force that we want to generate. I have a whole lot of tables that say at 200 meters per second, the side force plot looks like this. 5 degrees, 10 degrees, 15, 20. This is the line that the side force plot follows. This is very hard to describe without the spreadsheet in front of me, but the side force plot follows that line. And so at each speed we have that. And then I know how the slope of the line changes with speed. So it's not just that line, it's like a second polynomial on top of that. I know how the slope of that line changes with speed, and so I can compensate for that. And then finally, I know how all of these forces change with pressure. And thankfully, it's a pretty straight shot. Pretty much no matter where you are, how the pressure is going to change it. It's not exact, but it's close. And so then there's a pressure scaling factor as well. I don't remember the exact order that it goes, and it's quite a lot to recite off from memory. But yeah, it seems to work pretty well. Let's see. Do you use Starlink to track the rocket data? Nope, I do not. I am just on Verizon or something. and for rocket data, it's all just ground station, not going to the internet. Any experience with RTOS on flight computers? Nope, I do not have any of that. Will you have live video from the space shuttle rocket? No. If you are Indian, you better learn rocketry from him for missiles. All right, I'm timing you out, dog. We're gonna keep the conversation to non-missile rocket stuff. How about that? If the camera spinner is a dead idea and the rocket isn't going to be spinning, are you concerned about the loss of stability higher in the atmosphere? I have to relook at when the upper stage burns out, because the rocket it's not just the roll axis that's controlled. The ideal is that we're controlling the pitch and yaw as well. So I don't anticipate a full loss of stability. A lot of the spinning stuff, I don't know. I honestly, I don't know that I have a really good answer that I can stand behind for you. Yeah, I don't know how I don't know that I have a really good answer on that yet. Do you have any tips on moving through rocketry stuff projects quickly? Things that help take days out of the checklist, make iterative design faster. I think having one of these, a physical piece of paper where you write stuff down and check it off. At the beginning of the day, I write down a bunch of stuff that I want to do. Right now, this is just stuff that I want to talk about on the stream. But at the beginning of the day, you write down a bunch of stuff that you want to get done, and you're never going to get it all done. But at least I don't. Checking it off feels really, really good, and progress is motivating. Momentum is motivating. So as soon as you start the ball rolling, it's a lot easier to keep it rolling. Can you explain how the transfer function for TVC gains work? Well, those are kind of two different things. I use a transfer function to define how the servos rotate. So the servos, when you tell a servo, I want you to go from 0 degrees to 90 degrees, it doesn't instantly go to 90. It has a curve. There's a little bit of a delay before the servo does anything, and that could be from your computer, it could be from the servo's internal filtering, it could be from all sorts of stuff. It has a deadband, and then after the delay, there's a shape of a curve where the servo horn rotates to 90 degrees. Sometimes it's totally linear, sometimes it's an S curve. Maybe if it has a lot of metal heavy gears, it's sort of like a sine wave or an S curve.
Yeah, and so the transfer function represents that MATLAB has a system identification toolbox that will take that data. If you stick an IMU on the servo horn and rotate it a bunch, you can feed that data into MATLAB, and MATLAB will be like, oh, I've like fit transfer function curves to your data. You can have these. And you're like, thank you so much, MATLAB. And then you can take those and do other stuff with them. Yeah, so it's not really about the TVC gains. It's about modeling the actuators. So it isn't a lookup table, but rather a model. I would be interested in a video on this. Maybe I'm on Patreon. Shout out the thumbs up. Let's get some confetti in the house, please. Thank you. Can we get some lasers up in his house? There we go. Thank you. Very, very nice. Yes, so Paul, it is not a lookup table. It is sort of. It's like if you had a lookup table and you were like, I don't want to store all of this data on my little tiny microcontroller. So you just defined a bunch of curves for how that lookup table works. I'm working on an electric hopper, and I'm wondering how accurate the GNSS needs to be in order to have it have good control of position. I only had traditional accurate GNSS on Sprite, so 2.5 meter resolution or whatever. It's usually a little better than that, but yeah, no, that's all I had, and it was good enough. Just keep your landing legs kind of wide. Let's see. What are some of the important software which you use in your daily process related to Rocket? Google, Gmail. I don't really use a lot of software for Rockets daily. OpenRocket, I guess. Let's see. Thank you, Joe. Love your work. You're a big inspiration for me. Probably the reason I'm going for my L1 soon. Heck yeah! Get your L1. That's awesome. Good luck. Dr. Pepper is the secret ingredient of Joe's propellant. Thank you, TIFF currently. Does anyone know where TIFF is going to be non-currently? We know where TIFF is currently. When are we going to talk about TIFF non-currently? I can't think of a good joke. Have you thought about Ava having issues with the cold temp in space and having no way for the parachutes to eject the space shot? Those are two different things. Ava is probably not going to have a problem with the cold temperatures in space because in the same way that it's cold in space, there's also no air to take away the heat. So you lose your convection cooling, which means heating up is actually also a concern. Either way, we spend very little time in space on the space shot, so I'm not that worried about it. And then, what was the other question? Oh, ejecting parachutes. Yeah. High altitude charges are really hard. I have not solved that problem yet, so I have no good answer for you. That is hard. All right, here we go. If you can de-spin the rocket, you can most likely spin the rocket at the exact frequency, like 60 hertz, so your camera will be in the same place every frame. Would this work? No, because most cameras use a rolling shutter, so you won't be able to see it. But if I do this really, 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 really fast, and you were to pause the video, I don't think it'll really work on this. This looks ridiculous. If you were to pause the video on my arm would actually look a little bit like this, right? Or a little bit like that. It's called rolling shutter, which means that as this camera is recording data, it's recording data like this, all the way down. Every line gets recorded like that. And so you can fight this with something called a global shutter, where it takes a picture of every single pixel at the exact same time, and that's called a global shutter instead of a rolling shutter. But that doesn't actually fix the problem. So if you're spinning at 60 hertz and you're taking a picture at the same point every time in the rotation, you also need to have a shutter speed that is fast enough that you don't get any blur. And we can do some quick math. If you're spinning at 60 hertz, I don't want to do this math. I have no interest in this. But if you're spinning at 60 hertz, you would have to expose for like 1/20,000th of a second in order for it to be, it's just like, it's a fun technical thought experiment, and it's not a fun practical experiment. How do you get the PID values? Do you just try values? There are some rules of thumb that you can use, but for the most part, you create a simulation, you start tossing in values, and you see what works. Do Do you think it's a great idea to start with an Arduino card, at least at the beginning of making flight computers? Yes, Arduinos are great. There's tons of good resources online of how to code with them, how to hook up sensors, how to do wiring for them. I think it's like one of the best things you can do if you want to get started in electronics. Buy an Arduino kit with all the little like, sensors and like starter kit stuff that it comes with. Buy one of those and just poke around, try stuff, burn a few electronics, blow some stuff up. You could probably use roll-arounds to maintain stability. Yeah, and also no. I don't care about roll-arounds. They're like it would make a great video. I think about this a little bit. If I wanted to, roll-arounds would make a good video, but if I can get active control to work, that's 1,000 times better and probably more lightweight than roll-arounds. Are you going to balls this year? I don't know. I have no plans to, but maybe. Earlier, you talked about how you get the PID values for your rockets using a set of polynomials. Will you ever make that algorithm open source? Probably not, because that's like 4 years old now. So I wouldn't even stand behind what those values are. Yeah, but I did, for the Signal app, that's how the PID tuning in the app works. But there are better methods that are that are going to be more accurate, like Ziegler-Nichols or LQR. Yes. Have you had problems with Ava overheating at all? I have not. The J in Joe Barnard stands for jelly. That's so true, Kyle. More people need to be talking about that. I wish more people would be talking about that. Let's see. Rolling shutters are why so much aviation footage looks terrible. And static fire footage. You see it in like liquid static fires too. The fire looks like it's got all these lines through it. That's rolling shutter. And that's an effect of like when you have combustion instability and you're filming a liquid rocket engine. That's how you get those like light and dark areas that are stacked in the flame as it shoots sideways. That's rolling shutter. Do you still have plans to eat APCP propellant on your deathbed? Yes, absolutely. 100%. I think like if I know, and it requires that like if something happens to me and I know I'm going to die in, let's say 30 minutes, maybe if I knew I was going to die in 10 minutes, I would take a bite. I would take a bite of APCP. I would chew it and I would swallow it. But it's got to be really short because the stuff that it'll do to you inside is probably not very good. Would you go on a Starship in a few years if you get offered for free? No, I would not go on a Starship for 10 years at least. Do you use internal filtering on the BNO055 or just the raw data and filter yourself? Raw data and filter it myself. Actually, I don't even really filter it. There's like a Kalman filter, but the Kalman filter is about position and velocity. Yeah, I just use raw gyro values. Now that you've demonstrated propulsive flight with an open cycle solid, are you planning on applying for the DARPA scramjet funding? No, but the Navy did have a bid out for throttleable solids, and I thought about it a little bit, and then it was not something I wanted to do. But no, I'm not applying for the scramjet funding. Have you intentionally flown one of your motors yet, not including the one that blew the forward closure off? No, I haven't. Hopefully this summer. First flight of Risky Batman. Explain code in videos. It make the video more interesting. Thank you. Well, that is probably all that I have for you right now. And yeah, this was kind of a longer one. How long did we go? Like an hour and a half? I do use 5-micron aluminum. That's correct. Yeah, thank you for joining. So let's look at a calendar and find out when the next one is going to come out. Give me a second here, folks. I'm going to hop into the YouTube studio, find a little cheeky Patreon update here. 1 second. Okay, so the one we just watched was published February 17th. And then the next one is going to be March 2nd, where it's called Motorcase Bolt Grain Facing Oh My. Patreon update March, I guess, 3rd or 2nd. So yeah, sometime
I would say honestly, like 2 weeks, sometime in 2 weeks, we'll be back with another one of these live streams. We'll hang out. We'll take a look at what I was doing a year ago, and then we'll just like sit here and chat for a little bit. I enjoy these things. It seems like y'all enjoy these too. I appreciate you hanging out with me for this and maybe having some Dr. Pepper along with me. I love my Dr. P. Once every 2 weeks. I don't really drink it that much, but it's fun to do it on live streams. Yeah, and that's all I got. So one more time, if you want these updates in real time, they are on patreon.com/bps.space_government /shop/Mr. Beast Feastables. So if you just enter that link, you will find it. But for real, it's in the description down below if you want to watch these updates in real time. I posted one yesterday. And if not, they'll come out a year later. And then there's a bunch of information that comes out on the public BPS space page too. So anyway, thank you very much for watching. Thanks for hanging out. And I will talk to y'all soon. Happy Wednesday. Goodbye.